everyone, welcome to our channel Knowledge of. Friends, subscribe to our channel and click the bell icon for the latest update. आज हम लोग जो करने वाले हैं वो कंप्यूटर नेटवर्क की क्लास करने वाले हैं, जो कि कंप्यूटर नेटवर्क की भी अगर हम बात करते हैं तो दिस इज़ योर क्लास 6। ऑलरेडी हमने क्लास 5 कर लिए हैं, जिसमें हमने यूनिट 1 कंप्लीट कर लिया है, इंट्रोडक्शन टू कंप्यूटर नेटवर्क, और हम यूनिट 2 भी मोस्ट ऑफ द टाइम लाइक 1/2 से ज़्यादा कर चुके हैं। दैट इज़ योर यूनिट 2, दैट इज़ योर मीडियम एक्सेस सब लेयर। होपफुली आज के क्लास में अगर ये मोर देन 1 आवर नहीं जाता है तो होपफुली आज के क्लास में हम यूनिट 2 कंप्लीट कर लेंगे। दैट इज़ अ मीडियम एसेंस सब लेयर हियर। सो फर्स्ट ऑफ ऑल विल गो अहेड विद दिस। एंड लास्ट क्लास में हमने क्वेश्चन किया था ऑन द सैटेलाइट, इफ आई विल बी टेलिंग यू अबाउट द थ्रूपुट एफिशिएंसी हमने डिस्कस किया था, और हमने क्वेश्चन किया था कंसिडर द यूज ऑफ द 10K बिट साइज फ्रेम ऑन 100 Mbps सैटेलाइट चैनल विद 270 ms डिले, and what is the length utilization for the stop and wait ARQ technique assuming the p equals to 10 to the power minus 3, जो कि 5 मार्क्स में पूछा भी गया था, हमने वो किया भी था। आज हम फिर एक और क्वेश्चन से स्टार्ट करेंगे, दैट इज़ इन द रेफरेंस टुवर्ड्स 5 मार्क्स क्वेश्चन, उसमें भी पूछा गया है। एंड दैट द क्वेश्चन इज अ चैनल हैज़ अ बिट रेट ऑफ 4 kbps and a propagation delay that is of POF 20 ms CSC, and for that what will be the size of the frame range so that stop and wait give an efficiency at least 50%. That will do it here, and for that sake here, so where the question we have here is that is your a channel has bit rate of 4 kbps and propagation delay, that is POF 20 MSC, then what will be the size of frame range so that stop and wait give and efficiency of at least 50%. So this has been asked of 5 marks, so we'll go ahead with the solution here. Just repeat the question here, that is a channel has a bit rate of 4 kbps and a propagation delay POF 20 MSC, and what will be the size of the frame range so that stop and wait given efficiency at least 50% here. So with the regard of it, if I'm talking about with the solution, so here the data rate has been given, that is data rate equals to 4 kbps here, and in the same case that has been given here, and with the same case the bit duration equals to 1/4000, that is equals to 0.25 ms, and the time to transmit frame transit frame is, that is your t frame equals to frame here with this, that the t frame we have to find it out, that is your frame size upon bit rate. And the bit rate we will go ahead with the frame size multiply bit duration. So for stop and wait control efficiency, that is your efficiency u equals to 1/2a plus 1, and same where we have a equals to t prop slash t frame. For that we have to find it out t prop, and which has been given here. So in the same case, t prop equals to 20 ms, and solving this equation with respect to a, we will get a equals to 0.5 1 upon u minus 1. With the same case, for where that u is greater or equals to, that is 50%, then that is 0.5, and then a is less than equals to 0.5. we'll put the value here for in the within this equation. So we'll put the value here, that is your a is less than equals to, that is your 0.5. 1 upon u is 0.5 minus 1, and while solving this we'll get here as your a is less than equals to 0.5 as well. A less than equals to 0.5 here, and since a is your, that is your t prop and t frame, and that is a is less than equals to t prop t frame, and which is that less than equals to 0.5 here. So t frame greater equals to 2 t prop, but frame size equals to t frame slash bit duration, and where frame size is greater equals to 2t prop, bit duration which is equals to 2 into 1020 meters second, just like upon 0.25 ms, and which will get 160 here. So this is what the solution is. 5 मार्क्स से पूछा गया है, बट इसमें बहुत सारी चीज़ें करनी भी हैं और आप कह सकते हो नहीं करनी भी है, because that is easy as well. So now we'll discuss about the cyclic code. For the cyclic code, we will do first a question here, that given a 10-bit sequence, that is 1010011110, a divisor of 1011, then find the CRC and check your answer. This has been asked in 14-15 of 5 marks, so that is very important as well. So we'll go ahead there. The question we have here, given a 10-bit sequence 1010011110 and divisor of 1011, find the CRC and check your answer. This has been asked for 5 marks, so we'll do the solution. The sequence after adding, that is n equals to 3 and extra zeros, and divisor of length f, was that is your 101001111000 and 0. We are adding the zeros here, and the divisor of length n plus 1 will be, that is your we can say that divisor of length n plus 1 1011. With this concept we will move ahead here, and with the same concept here, that is 1011 will divide it out 1011111000 and 0 as well. So we'll get it. First we'll go ahead with the 10111 in the same case. So here 11011, then we'll get 1011, and for that same case we will be getting it out in the form of then we will go ahead with 0 as well, and then of course 001 00011. For that we have 1 0 1 1 0 1 1 0 0 1 0 1 1. Solve it out. 1 1 1 0. Then here it is 1 0 1 1, and for after that 1 0 1 0 and 1 0 1 1 0 0 1 here. So this will the remainder polynomial is 1, and so the CRC is that is your 0 0 1 here. So this will be the CRC because the remainder polynomial is 1 here. Okay, so after this what we had done here, this is the solution of a particular question what they had asked you about. Now we'll go ahead with the detail of like what are the requirements of CRC that we will be discussing here. Requirements of CRC. In the terms of requirements of CRC, we'll talk about, this has also been asked of 5 marks. The requirements of CRC, that the environment interfaces and the physical defects and the communication media that can cause random bit error during the data transmission. Error coding is a method of detecting and correcting these errors to ensure information is transferred intact from its source to its destination. The cyclic redundancy check, that is CRC, the full form of CRC is cyclic redundancy check, is a technique used for detecting the errors in the digital data but without making the correction. When an errors are detected here with this that it is used in the data transmission or the data storage integrity check, the CRC in a powerful and an easy implemented technique to obtain the data reliability. In the same case, the CRC, that is the cyclic redundancy check, is based on the polynomial arithmetic, and it computes the remainder of the division of the polynomial in GF2 by the another, and the remainder that are called checksum, while the dividend is the data and the divisor is the generator polynomial. In the same case, in the CRC, that a sequence of redundant bit called cyclic redundancy check bit that are appended to the each end of the data and unit, so that the resulting data unit becomes exactly divisible by the second and predetermined binary number as well. At the destination, the incoming data unit is divided by the same number, and if at this step there is no remainder, the data unit is assumed to be correct and is therefore accepted as well. The remainder indicates that the data unit has been damaged in transit and therefore must be rejected as well. Now we'll go ahead with the question, that is, which of the following CRC generator guarantees the detection of a single bit error? That is, the first is your x plus 1, the second we have is your x square plus 1. So this has also been asked of 5 marks. In the single bit error, only one bit is in the data unit has changed, so for that we have sent and receive as well. And then of course we have 1 0 with transmitting. This is the sent and this is received. Then we have 8 as well. This is sent, this is received, and for this here from one from here, this is, it will goes towards it. So with the transmission bit I will write it down 0 0 0, and then again 0, then again 0, and then again 0. We have 1 0, then 0 0 0 0 1 0 1 0. So for that 0 से लेके that is got to the one digit bit, and for that say it will be transferred 0, that change 0 changed to 1. So here that the transmit bit has been changed here from the same case. Now we'll discuss in the detail of this, that is, if the generator has more than the term of the coefficient x to power 0 is 1, then all single errors that can be caught, and to detect the single bit error, a CRC generator must have at least two terms and the coefficient of x power 0 must be non-zero. And for that same case x plus 1, it meets both criteria. No x up power I that can be divisible by x plus 1, and any single bit error that can be caught. This is a very poor choice for the generator, and any two errors next to each other cannot be detected. X to power square plus 1, it meets both criteria if it is equals to the greater with greater than the 3, then x to power I is divisible by g of x, and all the single bit error in the position is 1, 2, 3 are caught here. So with regard of it, now we'll talk about the Hamming code. The reference towards the Hamming code here, this has been asked in 1516 of 15 marks. So the Hamming code is very important towards your syllabus, and for that Hamming code, if I'm talking about, the Hamming bits are inserted into the message at random location, and Hamming code is a single error correcting code, and it is the most complex from the standpoint of creating and interpreting an error bit. And let us consider the frame, which consists of m data bits and r check bits, where the total length of message is your n equals to m plus r, and the n bit using containing the data and the check bit is often referred to as an n bit code word here. Now with this references here, that what we have to deal with it. And in the same case, as I told you about the Hamming code, that Hamming code is a very important topic that has been asked, of course, of 15 marks. So you don't have to write that too short, but you have to be very long when you are writing with that. If 1000 and 1000 and 10110001 are the two codes, and then corresponding bit differ in these two code word is 3 bits, and the number of the bit positioning in which the two codes word differ with is called as Hamming distances. If two code words are Hamming distances d apart, then it will require a single bit error to convert one into the other, and determining the placement and the binary value of the Hamming bit that can be implemented using the hardware, but it is often more practical to implement them using software as well. The number of the bit in the message are counted and used to determine the number of Hamming bits to be used, and the equation is to be considered the number of the Hamming bits. For that we have here is your 2 power h is greater equals to m plus h plus 1, where m is your the number of bits in the message, and where h is your Hamming bits here. Okay, with the regard of it, after calculating the number of Hamming bits, the actual placements of the bits in the message is preferred, where the Hamming code works as follows. Like suppose the frame consists of 8 bits, so that is m1 m2 m3 m4 m5 m6 m7 and m8 until that was the 8 bit code here. And the Hamming, where if n parity checks are used using the 2h possible combination failure and success as well, and if we use 4-bit parity check, then there are possible combination of parity successes and failure as well. The total 12 bits are sent which contain 8-bit original message and 4-bit parity bits, and the 4-bit parity is inserted into the frame. The 4 parity bits are P1, P2, P3 and P4. Let us consider the following. We will draw a data bit and as well that is your Hamming bit as well, and where we check the Hamming code for the parity bit as well as for the Hamming bit as well. So let's go ahead with this. So this is Hamming code, this is data bit, where it is, this is P1, P2, then this is M1, M2, M3, M4, M5, M6, M7, M8, and then of course we have 2 as well. Okay, so for that here, and with this same reference we have 1 2 that Hamming code, we have 1 2 3 4 5 6 7 8 9 10 11 and 12. And for that same case, here we have the M1, then we have parity 3, then after that M2, M3, M4, then we have parity 4, and then of course we have M5, M6, M7 and M8. So here these were the Hamming code where the parity bit are, that is has been introduced here. That is your the parity bits are inserted into the message position of the parity bit, that is calculated as follows. Like create a 4-bit binary, and that is of B4, B3, B2, and in the same case where the B of I equals to 0, and if the parity check P of I succeed, then Bi is equals to 1, otherwise I equals to 1 2 3 4 for here. The parity bit Pi is inserted as a bit position 1, and for even the parity for the bit position in the same case, that is your 1 3 5 7 9, and in these bit the position it contains even the numbers of zeros or the ones as well. The parity bit P2 is inserted at bit position 2 for even parity for a bit position 2 3 6 7 and 10 and 11. The parity bit P3 is inserted at a bit position 4 for every parity of the bit position 4, 5, 6, 7, 12, and the parity bit for B4 is inserted at a bit of position 8 for even parity of the bit position 8, 9, 10, 11 and 12 as well. For that same case, for inserting the parity bit even or odd parity that can be used, each parity bit is determined by the data bit, and it's checked when a receiver gets a transmitted frame, and it performs each of the parity checks, and the combination of the failure and the success then determines whether there was no error, or in which the positions and the error occurred. Once the receiver knows where the error occurred, and it changes the bit value in the position, and error is corrected as well. Now for the Hamming distances, if I'm talking about here, with the regard of it, the Hamming distances, the Hamming bit are inserted into the message at a random location, and a Hamming code is that singly that what we had discussed about it. What is that a Hamming code is inserted into the message at a random location, and Hamming code is a single error correcting code, and it must be complex from the standpoint of the creating and interpreting the error bits. Let us consider the frame, which consists of M data bit and an R check bit, and the total length of the bit, as I told you about, that is n equals to, where we had discussed about it as well, that for the n equals to here, that is M plus R, and that we introduced it, and that we had written as well here. And in the same case, that an n bit unit containing the check bits is often referred to as n bit code word as well. If you are taking 10001001 and 1011 or 0001 are the two code words, then the corresponding bit differs in these two code words is 3-bit, and the number of bit that possible in which the two code word differs called your Hamming distances, where if the two code words are the Hamming distances d apart, so it will require the that d single bit error to convert into the other, determining that the placement binary, and for the binary value of the Hamming bit that can be implemented using the hardware, but it is often more practical to implement them using software, and the number of the bits in the message are counted and used to determine the numbers of bits to be used And the equation in these to count these number of hummingbirds is, as I told you about, that is 2 to power h is greater than equals to m plus h plus 1, where m is the number of bits of message and h is the hummingbirds as well. Okay, in the same case, if I'm talking about with it after calculating the number of hummingbirds, the actual placement of the bits into the message is performed, and humming code works as follows. Like suppose the frame consisting of 8 bits, that is m1, m2, m3, m4, m5, as I told you about it. We had done that in an parity checks that are used, and that a possible combination of the failure and the successes. So if we use the 4 parity bit, then there are the 16 possible combination of the parity success failure, and of course the total 12 bits are sent, which contain the 8 original bits, and this is for 8 original bits, the 4 parity is inserted into the frame, and the 4 parity p1, p2, and p3 and p4, and this has been inserted in the data bit. These were the Hamming code, and these were the parity bit has been used here. In the same case, for inserting the parity bit even and odd, that can be used a bit that is determined by the data bit is checked, and when the receives get transmitted frame, it performs the parity checks combinations of the failure and the success that determines no error or in the positions which an error occurred, and once the receiver and the error correcting that has been done. So minimum humming distances, if I'm talking about here, with the minimum humming distances, that is d minimum, and that the maximum humming distances is the smallest humming distances between all possible pairs in the set of worlds, and that to find it out with this, which we have here is your that is your to find out the d minimum. We find out the humming distances between all the words, select the smallest one. Now we'll go ahead, we'll discussing the short answer question of 2 marks, which is very important as well. Now we'll discuss about it, that is the short answers. I told you in what situation the connection that contentions based on the MAC protocol suitable. So the contention based MAC protocol are suitable at a lower load condition. That has been asked of 2 marks, so that is lower load condition here. Now we'll discuss about the compare and contrast between CSMA and CD, and with CSMA CA. Okay, so we'll discuss at least, because this has been asked of 2 marks, so we'll at least discuss 4 points with one to another. So for the CSMA CD here, that is the collision detection technique, and for the CSMA CA, that is the collision avoidance technique. CSMA CD, that the common used in LAN. CSMA CA, that is commonly used in the wireless network. CSMA CD is based on the sending jam signal method, and CSMA CA, that is based on the enter frame space contentions window and acknowledgement. CSMA CD, that is energy is wasted during the collision, and CSMA CA, that is energy is not wasted as collision avoided. Now this is the 4 differences that we had discussed of 2 marks, and that is very important because this is very easy as well, as we had discussed before as well. So now we'll discuss about explain the different difference between the 10 base T and 10 base 2 cabling here. So with the 10 base 2 and a 10 base T here, that is difference between, this has also been asked of 2 marks, between 10 base T and 10 base 2 cabling. Okay, for that we have to make a sort of a table where we'll discuss this in detail, and for that we have here is your, that is the medium, with this medium, and then we'll have to discuss about the transmission media. Then we have signaling technique, data rate, that is Mbps, and then max, that is your maximum segment length. So we'll discuss one by one. For that same case, we have 10 base T. In the 10 base T, the transmission medium is unshielded, twisted. For the unshielded, that is your baseband, 10 Mbps the data rate, and that is maximum segment length, that is in 100 meter. For the twisted here, that we have is your, that is Manchester. Now for the 10 base 2, that is coaxial cable, baseband, data rate is 10 Mbps, and the maximum segment length we have is your 185 meter. And for the 10 base 2, the another we have 15 ohm. This is Manchester. So this is a sort of a table you have to draw of 2 marks, and that what they can ask you about like a difference between the 10 base T and 10 base 2 here. So then you have to draw this and you have to mention this as well. Okay, now they can ask you why and how is a bit stuffing is used in framing. So bit stuffing is used in that is in your that is in the case of framing, so that you have to introduce here. And in the same case here, that we have to discuss about it, that is in the same case of bit stuffing, and that is we'll discuss here. Bit stuffing used in framing. Here we have to start with the how and bit stuffing and used in framing. So in the bit stuffing, specific bit is stored in the outgoing the character stream that the format to be followed, and that is we have data. So the bit stream we have here 0 1 1 0, and then we have 1 1 1 1 1 1 1 1, then 1 1 1 1 1 1 and 1, and then we have again. So with this 16 1, and then of course we have 0 0 1 0. This is of data. Now for the another one, after bit stuffing, what it will be, that is your 0 1 1 0. Then we have here, that is after individual 5 1, we have 0 1 1 1 1 1, and then 0. Then after that, when again 5, we have 1, then n 2 3 4 5, this is 1, then again 0, and then of course we have another 5, and then 0 1 1 1 1 and 1, then we have 0 here, and then again we have 1, then 0 0, and then 1. So this is where this 0, and for this, because ये आपके डेटा में नहीं था, ये 3 0, this is are known as stuffed bit. Okay, so this is bit stuffing. So each frame begins and ends with a special bit pattern, that is your 0 0 1 1, and then 1 1 1 1, then 0. So this is the another fixed pattern code, and a flag byte which 5 consecutive ones are encountered in the data automatically with the stubs as 0 bit into the outgoing bit stream here. Now we'll discuss the question here, that we have to do it. And for the Aloha, that is, the question is, measurement of the slotted Aloha channel with the infinite number of the users shows that the 10% of the slots are idle, and what is the channel load, you have to find it out, and what is the throughput, that we have to find it out. So these two things we have to find it out. So let's go ahead here. That is measurement of slotted Aloha channel with infinite number of users show that the 10% of slots are idle. The first part we have is what is channel load, and the second part we have here is your what is throughput. Okay, so for that we have to draw a solution here. In the same case for this question, let's go ahead with the solution. For the slotted Aloha channel, this has also been asked of 2 marks. So for the slotted Aloha, the probability of a single transmission during the slot time is equals to e to the power minus g, what we had discussed, and 10% equals to e to the power minus g here, and as well for that 0.1 equals to e to the power minus g, and minus g is equals to minus 2.3 here, and where g is equals to this, minus cancel it out and we'll get 2.3. Now for the s is equals to g multiply e to the power minus g, and where it is equals to 2.3 multiply e to the power minus 2.3, and with the same regard of it, that is your 0.23. For the slotted Aloha, that what is the maximum at that at g here equals to. So for that for the slotted Aloha, s is maximum at g equals to 1, so where g is equals to 2.3 and s is equals to 0.23 here. So this is the value what we had find it out, and it is beyond g is equals to 1, so and it is overloaded. So now with this term, now we'll discuss how many layers are there in the X.25 protocol, and less the layers as well, that what we had discussed even though in the last classes, where there are the 3 layers or in X.25. This has been asked of 2 marks. The physical layer, frame layer, and a packet layer. In a physical layer that deals with the physical interfaces between an attacked station and the link that attaches the station in a packet switching node as well. The second layer we have a frame layer, where the frame layer that facilitates a reliable transfer of the data across the physical link by transmitting the data as a sequence of frame. The third is the packet layer, which is responsible for end-to-end connection between the two DTEs as well. The another thing they can ask you is what is single bit error. It means that only one bit of the given data until a unit is changed from 1 to 0 and from 0 to 1. A single bit error is an isolated error condition that alters one bit but does not affect nearby bits as well, and a single bit error that can occur in the presence of the white noise when a slight random deteriorations of the signal to the noise ratio is sufficient to confuse the receiver's decision of a single bit, and single bit error are the least likely type of the error in the serial data transmission. Now they can ask you of the 2 marks is that is what do you mean by the redundancy. In the what do you mean by the redundancy here, the redundancy is the form of an error detection where each data unit is sent multiple times, that is the twice, and at the receiver side the 2 units are compared, and if they are same, it is assumed that no transmission error has occurred. And redundancy is a character redundancy and a message redundancy. When the data unit is a single character, it is called character redundancy, and where if the data unit is the entire message, it is called message redundancy there. With the same concept, what is the flow control, and they can ask you or define the flow control. So in that same concept, the flow control is a technique for a speed matching of transmitter and a receiver. Flow control ensures that the transmitting stations does not overflow a receiving station with the data. Same case, what is ARQ, and that in an error control, which when an error is detected in an exchange of specified frames are retransmitted, this process is called ARQ. what is Hdlc, and which Hdlc is a protocol that implements ARQ mechanism, and it supports the communication over a point-to-point or a point-to-a multi-point links as well. Give the data transfer modes of Hdlc. So here that the first mode is the normal response mode, the second is asynchronous response mode, and the third is that asynchronous balance mode. They can ask you how many types of frame Hdlc uses. So there are the three, that is U frame, one frame, and S frame. U frame, I frame, and S frame here. Next question they can ask you, state the phases involved in the operations of Hdlc, where they can ask you, you have to answer the three phase operations in Hdlc, that is the initialization, data transfer, and disconnect. Same for the same case, that is what is the necessity of the flow control. In that same case, when the sender is running on the fast machine or lightly here, same references that they're running on the fast machine on a slightly loaded machine, and the receiver is on a slow and a heavy loaded machine, then the transmitter will transmit the frame faster than the receiver that can accept them. And even if the transmission is error, then a free at a certain point of the receiver, that will simply not be able to handle the frames as they arrive and will start to lose some. So to prevent this, flow control mechanism is incorporated, which includes a feedback mechanism requesting the transmitter a retransmission of incorrect message block as well. Now we'll discuss about define the flow control and error control. For the flow control here, that the flow control is a set of procedures used to restrict the amongst of the data, and that can be send before waiting for the acknowledgement as well. That is a flow control. For the error control here, error control is a mechanism of retransmission of data by the automatic repeat request, that is ARQ. Error control involving from the error detection and the correction as well. So now what is the difference between the P persistent CSMA and the non-persistent CSMA? In the non-persistent CSMA, when a collision occurs, the transmitting device set a timer, waits for the period of the time the checks against to determine if the medium is free. Then of course, if the media is that is free, the station will immediately transmit the data. And in a persistent CSMA here, that the devices warning wanting to transmit does not immediately send the data, and when it detects the media, it's idle. Instead, it uses a random scheme that gives it enough 50-50 chances to the either send to the data immediately or to wait and then repeat the process as well. The next they can ask you is what is the Aloha Protocol. An Aloha Protocol is a packet radio protocol in which the station sends a packet, and if it's collide with another, will send another after a random amount of time. Now the next is that is what is CSMA. So CSMA is a protocol used to sense whether a medium is busy before attempting to transmit. The another one is what is CSMA-CD, that it is a protocol used to sense whether a medium is busy before transmission, but it has the ability to detect whether the transmission has collided with another. The next question they can ask you is in the reference towards it, difference between Aloha, that is pure Aloha, and of course the slotted Aloha. For the pure Aloha, that is each station transits a packet whenever it is ready to send. For the slotted Aloha, a station that can transit data at specified time slots only. For the pure Aloha, inefficient channel utilization is 18.4%, and for the slotted Aloha, the channel utilization is 37% here. The next and the last question of the session here, that we will complete the unit 2 completely, that is the medium access sublayer. That is the list out the various features of sliding window protocol. So the key feature of the sliding window protocol is that to permit the pipeline communication. So for that, first we have frames are numbered, last frames can be retransmitted. The C is to duplicate the frames that can be deleted, and out of the order frames that can be recorded here. So here we'll end up with this class, and first of all, it's a huge request from my side to all the viewers, please go through with the subscribe button and please like, share and subscribe our channel, so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. As of now, we had completed unit 2. So where we had completed the first unit, that is your introduction part, and in the introduction concept we had completed the goals and application of network structures and architecture, the OSI references, model services, network topology design, delay analysis, backbone design, local access network design, physical layer transmission media, switching method, ISD, and terminals handling, that we had discussed in the unit 1. In the unit 2, that is medium access sublayer, the medium access sublayer, the channel allocation, LAN protocol, Aloha Protocol, overview of IEEE standard, FDDI, data link layer, elementary data link protocol, sliding window protocol, and error handling, that we had covered up. Now we'll discuss in the next coming class, that is of your 7th class, is your network layer, that we will discuss about network layer, point-to-point network routing, congestion control, inter-networking, TCP, IP packets, IP address, IPv6. Then in unit 4 we have to discuss here, that is your transport layer, design issues, connection management, sessions layer, session design issues, remote procedure calls, presentation layer, design issues, data compression technique, cryptography, and TCP, that is window management. Then in the unit 5th we have to cover up application layer, that is application layer, file transfer, access and management, electronic mail, virtual terminals, other application examples, network, internet, and a public network, that what we have to cover up in the next coming classes. It's a huge request from my side to all the viewers, please go through with the subscribe button and please like, share and subscribe our channel, so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. And thanks for all those subscribers, those who had subscribed our channel, because of your support we had reached more than 2k subscribers, and thanks for supporting us. Thank you, hope you enjoy this video. If you like this video, please give a thumbs up and give your suggestion on a comment box. Thank you.